Welcome to our first lesson. This is for 1.1 and 1.2. If you have these notes out, feel free to fill those in as you go, or you can just go ahead and do this on notebook paper. All right, so you'll notice in these two lessons that we're dealing a lot with expressions. So a lot of our instructions are going to be to evaluate, we're going to be given values to plug in, and then order of operations are going to be something that we look at and review as a way in which to get to our correct answer. So you'll see here in example number 1, we would like to evaluate an expression, and in this particular case, and you'll see this also in your assignment, they're going to give you a value that goes in for the variable. In this case, it is 3. So here on example 1a, we're going to put 3 in for n. When we do so, we would get 13 times 3. Once you have it substituted, then you just go ahead and evaluate, and you can get 39. If you would like to use a calculator, that is totally fine. All right, so on B, we're going to do the same. We're going to plug 3 in for n, so we have 9 divided by 3. That gives us a total of 3. If you want to go ahead and pause here and do the 2 remaining, and then you can kind of double check if you've gotten them right, I'm going to go ahead and push play to show those responses. 3 minus a negative 1 gives us plus 1, which is 4. Last but not least, 3 plus 8 is 11. The other part of lesson 1.1 deals a lot with exponents. So you'll notice here we have the definition for a power. So a power includes the base and its exponent. In this particular case, the base of 2 to the 5th is 2. The exponent is 5. One of the things they'll ask you to do in your homework is to write that power out in expanded form, or what it would look like as a multiplication problem. In that case, the exponent tells you how many you have of the base. So in this particular case, 2 to the 5th is the same as 2 times 2 times 2 times 2 times 2. Now, example 2, and again, they'll do this kind of broken up in the homework as well. You're going to do the same as we did in example 1, but now you're going to experience some exponents. As a reminder, again, calculators are fine. Depending on the calculator you have, most will use what we like to call the caret key, which just kind of looks like a little angle pointing up. So as we plug items in and evaluate, we're going to put 2 in for x and 3 in for y. So for A, 2 to the 3rd is the same as 2 times 2 times 2, which is 8. On B, we're going to plug 2 and 3 in to get 5, and then we're going to square it to get 25. Next, we're going to plug 2 and 3 in and go 2 squared plus 3 squared, which is 4 plus 9, for a total of 13. Now, on D and E, we're going to have some similarities, which is why I have them filling in at the same time here. Notice they almost look the exact same. However, the placement of the parentheses does affect the order in which things happen, which we're going to talk about more here in a second when we look at order of operations. So, on example D, when we have 3 times 2 cubed, exponents trump multiplication. So the 2 cubed happens first, giving us the 8. 3 times 8 is 24. However, on E, both the 3 and the x are inside the parentheses, so we actually get 3 times 2 first, and then 6 cubed is 216. So pay attention to our order of operations. Last but not least, we're going to go ahead and plug 2 and 3 in for x and y. 2 cubed is 8. All right, so now moving on to lesson 1.2, which is about order of operations. If you haven't heard it before, our order of operations are PEMDAS, or please excuse my dear Aunt Sally. The original P represents parentheses, which could also represent brackets. That's just grouping symbols in general, so those will always go first. Followed by our exponents, so something that's written superscript or partially above our base. The next 4 are kind of done in groupings of 2. So we have multiplication and division. They happen left to right. So it doesn't necessarily mean that multiply always happens before divide, or that addition always happens before subtraction. You just do whatever occurs first as you read the problem left to right. So multiplication and divide is your next chunk, and then the last chunk is to add and subtract. So in these last three examples, we're going to kind of break it down. What do you see? Again, you'll notice it's just an expression. We aren't solving. We're just trying to evaluate what's there based on what we see using our order of operations. So on example 3a, you'll notice there are no parentheses. There's also no exponents. So our next thing to look for is multiplication and division. That happens twice. So if we go left to right, the division there is 4. Then we add the 4 in between because that's just kind of hanging out and waiting. The negative 2 times 10 is negative 20. And then we add on the 1. If we work this problem from left to right as we go down, adding and subtracting, we get that 8. Then we subtract 20, which gives us a negative 12. Then we add 1 for a negative 11. Even though it'd be awesome for you to do this without a calculator to test if you understand the order of operations, calculators are totally okay. Here on B, you'll see that we have parentheses and brackets. So whenever you're trying to determine, or especially if you have multiple parentheses, we use brackets to help you to see where the end and beginning of these grouping symbols exist. So we have the brackets that are doing the larger portion of this. And once we see those, then we dive deep inside of those brackets to complete the order of operations within, which leads us to 2 more sets of parentheses. So if we tackle those parentheses first, we should get 3 times 2 plus 4, which is 6, minus 2 times 4 minus 2, which is 2. All of that is still inside the brackets because we haven't simplified everything in correct or in all the way down yet. And then we have a times 2 on the outside. Next, we go ahead and finish up with the parentheses inside, which gives us 18 minus 4. We'll finish up our brackets, which should give us 14 times 2 for an ending result of 28. Last but not least, when things are written in fraction form, it's important to note that it's almost like putting parentheses around the top and the bottom so that the division portion happens last. So when you see this, bring some type of way or like extra like, hey, look, there's a division here, and go ahead and evaluate each portion separately. So I'm going to tackle the numerator first. You'll notice we did 2 times 3, which is 6. That was our parentheses. Then I moved on to exponents, so 6 squared is 36. And then last but not least, addition, which is 40. Then we tackle the denominator, so 1 plus 3 squared, which is 9. That gives us 10. And then lastly, the 40 divided by the 10, which is 4. So this is the one instance where division might not actually trump addition and subtraction, but it's based on the fact of how it is set up and what that means about the order in which it is done. And that's your first set of notes.